All right, let's resume. This is what we did last class. We'll be doing a very complicated thing, okay? So class is quite important. Is something that students struggle with, okay? So pay attention. So yeah, we are done with diffraction. Diffraction is just a recap of your O levels, which is when wave passes through a gap. As you change the size of the gap, you'll find that the diffraction changes, right? And diffraction is a spreading of the waves that take place when diffraction is the spreading of waves when they pass through a small gap, right? Now, the idea is that you have the highest amount of diffraction or spreading when the gap is similar to the wavelength. And if you can make the gap equal to the wavelength, that's the most amount of spreading possible, okay? Which means that it'll become perfectly semicircular like that, all right? So yeah, this is diffraction. Because it's actually just O-level version, nothing new here. So what's new here, to know, we need to understand something called pad difference, okay? So what you need to do is go to page 59. Page 59. I'll explain this using an example. The concept of path difference. So do you guys remember there were two things, phase difference and path difference? Phase difference was difference in waves in terms of what? Phase difference was the difference in two ways in terms of angle, right? And what is path difference? The difference in two ways in terms of wavelength. So what you need to take an apply. Don't worry if you don't remember, revisit. So the example is this, which is you have a microwave machine here, and I think it's like one of the best ways to understand path difference. Okay, so you have this microwave here, and you have a food that is going to be heated. So food taken rakha. The question says that the microwave is like a magnetron ball, if you remember from your O levels. It produces microwaves, and the microwaves bounces around the inner surfaces and comes and hits the food here, a spot. Now the thing is, the microwave, magnetron produces microwaves that go everywhere. It's not just act a line up. So one of the microwaves would just travel straight to this place as well. Do you understand what I'm trying to say? So there's a microwave that will go here, bounce off and come to the food, and there's another microwave that goes straight to the food, right? So other question chilo that if you have a microwave oven, then you can try this in your home and see if your microwave oven tray is not working, right? So let's say the tray is not working, or you remove the tray and you place your food there, right? For best experience, if you place like a pizza, the best, right? And what you do is you turn on the microwave oven, right? You'll find that the pizza gets heated at places, or sometimes you'll find that when you take your food out from the microwave, it's hot at some places and very cold at some places, right? So these are called hot spots and cold spots, and they're actually based on constructive and destructive interferences. So how does it work? So it turns out, if you have two microwaves that meet at a place, right? Due to microwave, they come and meet at a place, and if they're completely in phase to each other, what would they result in a hot spot or a cold spot? Hot spot, because the wave in phase again, they meet somewhere, right? Would that be constructive or destructive? Constructive. And doesn't constructive mean that the energy is amplified? There's more energy than normal, right? So this place will produce like a very hot spot. Very hot, right? But then you have a wave that goes like this, right? And meets another wave that is like that. So this will result on what? Destructive interference. And you'll find that the energy is not available, right? And that is the one. Right? So if the train is not used, it is not used for a train is used for a yeah, we are moving around. So the food will be going through hot spots eventually. There are hot spots in many places, and there are cold spots in many places. So train will right? But if you don't have the area, right? It is just the food there. You'll find that okay, solid then water even water right? So it's in your paper for 3 marks. তোমাদেরকে microwave বের করতে হবে that place where the waves interfere, like it is where the waves met, right? Is that a hot spot or a cold spot? That's what you need to figure out, right? Now, what are the other piece of information provided to you? So this is 15 centimeter travel course, 40 centimeter travel course, 25 centimeter travel course, and in a 30 centimeter travel course. That's the path taken by the wave. And the very vital piece of information provided was microwave has a wavelength of 0.8 centimeter. Okay, that is the wavelength of microwave. So microwave wavelength is 0.8 centimeter. So তোমাদেরকে যেটা করতে হবে, and I want you to try this because we have done this before, is figure out if this is a hot spot or a cold spot. Now let me give you some heads up. Randomly জিজ্ঞেস করা too difficult. So do you remember when two waves are perfectly in phase? What did they create? It's a wave perfectly in phase, right? When phase difference 0. What was it? Constructive or destructive interference? Constructive, right? But is it only when it's 0 or does it come back again? The constructive interference? Yes, when? Multiples of 2. Yeah, 360 or multiples of 2 pi. 2 pi, right? So যেটা হচ্ছে is eta. Okay, so you have these waves here. দুটাকে যদি compare করতে চাই phase এ, so let's say they both start together. Aren't they moving together? What's the phase difference? 0. But then this moves, goes up, and then comes back here. That's one cycle, and then they both start moving. Wouldn't they still look the same? But isn't this doing one extra cycle? One extra cycle constitutes how much phase? Like this extra cycle, like one cycle is how much phase? 360, which is how much? I'm pi তে বলি সবসময় 2 pi, right? আবার এটাও করতে পারবে না 1, 2, and then again it's back to the same thing. So how much is that? 4 pi. So you get my point, right? 2 pi, 4 pi, 6 pi, যাই করতে থাকবে they'll be completely in phase, right? Acha, and what if this happens? Like this is here, it goes to the top, and then they start. What's the phase difference? Pi. Acha, so you get my point. This is called phase difference, right? But we learned that phase difference ke RT unit represent kora jay, which is in the unit of what? Lambda, which is known as what? Path difference, right? So 2 pi is equal to how much lambda? 1 lambda, right? So amra jodi 2 pi, 4 pi, 6 pi hoy in terms of lambda, what should that be? Lambda, 2 lambda, 3 lambda, 4 lambda. So যখন lambda তে আসে, like in terms of path difference, it must be a what? Whole number multiple of lambda. Our phase difference is even multiple of 2 pi, or even multiples of pi, right? 2 pi, 4 pi, 6 pi, right? The one that I want you to focus on is this though. Can you tell me what is the path difference if it's out of phase? Path difference. What's the path difference if they're out of phase? Power by double. Lambda by 2, because lambda is the whole wave. Half hole out of phase. What's half? Lambda by 2. Next কখন হবে? 3 lambda by 2, then 5 lambda by 2, right? So what's the, remember we derived the general equation, which is sequence na tomdeke bolchilam n plus half lambda by 2 ekta jinish, right? Oi jinishta amদের জানতে হবে. So here's the thing. এখানে যেটা হচ্ছে, you have your wave traveling like this, right? এই উপরের দিকে যাচ্ছে, এই যে এখান থেকে এখানে এসে এখানে বাড়ি খাচ্ছে, আর এখান থেকে কিছু ওয়েভ এসে এই জায়গায় বাড়ি খাচ্ছে. So when they meet at this place, তোমাকে যেটা বের করতে হবে is their path difference. মানে দুইটা ওয়েভের ডিফারেন্স কত, in number of wavelengths. If that difference is a whole number, lambda, 2 lambda, 3 lambda, what does that mean? That the two waves যখন meet করে, what do they create there? Constructive interference. And if the difference is a half multiple of lambda, like 0.5, 1.5, তাহলে কি হবে? Completely out of phase. Completely is a very important word here. And what does that result in? Destructive interference. What if it's neither? Not like a whole number, not like a half. Then what would you notice? Still not shear. Interference. It's not completely in phase, it's not completely out of phase. What do we just call it? Interference. So it's the hottest of the hot spot hobe, no? Cold spot hobe, no? What would it be? Just warm, like, just basic like a warm place. So yeah, what you need to do here is do the math and figure out a spot, get a hot spot, make a cold spot. Is this spot going to be a constructive interference or a destructive interference, or neither? Okay, so see if you can figure this out. Sorry? No equation. ডিস্ট্রাকটিভ। আচ্ছা, বাকিটা ট্রাই করো, আমি বলে দিচ্ছি। Destructive. What's the path difference you find? 5/2 pi lambda. 62.5. I mean, based on what numbers you told me, destructive হবে, but numbers গুলো একটু দেখতে হবে। Just 2.5. Okay, করে দেই। একটু স্ক্রিনে দেখো, let me show you what's happening here. এটা না পারা, it's normal. I just want to see if you recall it or not. পারলে তো খুবই ভালো। So এই blue path এর মধ্যে there are waves here. মানে এখান থেকে যখন travel করতেছে, lot of waves are traveling like this, right? So এই যে এরকম wave যাচ্ছে এদিক দিয়ে, তারপর এদিক দিয়ে wave যাচ্ছে. So there are many waves that go like that. And as the waves travel like this, right, they eventually will come and end up at x. তোমাদেরকে যেটা বের করতে হবে is how many waves had taken their path to get to x. Like quite a wave chilo. So the bear kora khubi easy. Bear korba, you need to find the total length and divide that by what? The wavelength, right? So path, eta dhoro amra naam dei o a x. So o a x a, what's the total length here? 15. 15 plus 40 plus 25 divided by how much? 0.8. That'll tell me how many waves are out there. Can I also 0.8 divide করতেছি to know how many waves are out there? How many waves are out there? Exactly 100. Okay, 100 lambda. There are 100 lambdas in this path from the blue path, right? Now the path OX directly is going to be 30 divided by 0.8, right? Because they can nice. So how much is that? 27 point, oh, 37.5. So 37.5 lambda. So it means that a red path there are 37.5 waves out there. So basically the final thing is that when the waves come and meet at x, how many waves have reached in the blue path? Complete waves. Because our answer is 100 ashana. 100 মানে কি complete wave ashana. So at point x, you'll see a complete 100 number wave show up. Like, 99 and then x reach 100, right? But the red path gave us 37.5, which means ওইখান থেকে যখন আসতেছে is like 36, 37, and x যখন reach করছে is just 37.5. পুরো wave reach করে নাই. So when they meet, right, one wave has done its full cycle, the other has done half its cycle. What are they to each other? Completely out of phase, right? So এটা কেমনে বের করব? এটা বের করার একটা way আছে. So what you write next is path difference key. So path difference between the 2 points is equal to 100 minus 37.5, which is how much? 62.5 lambda. And tomra এত কিছু না করে, you just look at that number and see what criteria it fulfills. If this was a whole number, like 61, 62, 63, তাহলে কি হতো? Constructive. But this is what though? 62.5, right? Isn't that like a half multiple, right? So that means whatever happened here results in a what interference? Destructive. 61.4 to the ashto, তাহলে কি হতো? Just interference. Okay, so তোমাদের conclusion হবে, since the path difference, এটা একটু গুছায় লিখতে হয়, এটা অনেকের কনফিউশন হয়, আমি লিখে দিচ্ছি। Since the path difference satisfies the equationটা তার জন্য আমি তোমাদের প্রথমে বলছিলাম যে মনে রাখতে হবে what equation, general equationটা কি ছিল? n plus half lambda. এখানে n0 হলে কি হবে? lambda by 2. n1 হলে কি হবে? 3 lambda by 2. So since the path difference satisfies the equation n plus half lambda, where n equals to 0, 1, 2, etc., we can conclude that x is destructive interference. Right, so that's what you do. So the main purpose of this question is to introduce you the idea of what? Path difference. So do you understand how to work with path difference? Phase difference, okay, path difference is much more, I would say, visually easy to understand. Is, you know, you just take two paths, you find a number of ways that go this way, number of ways go that way, and you find when they meet, what number of ways are different about them. So আমার যদি একটা জিনিস হয়, এদিকে দেখো, 11 ways go here, 11 ways go there, and they meet at a place, right? What is the path difference? 0. তার মানে they perfectly match at that place. What would that be? Constructive, right? What if 11 go here and 12 come from here? Still constructive, কারণ আমার আরেকটা cycle extra হয়ে eventually তো একইভাবে meet করে, right? So it's easy to visualize. That's why path difference টা হচ্ছে একবার বুঝে ফেললে you'll find it easier. Okay, unfortunately, stationary waves এ path difference use করা যায় না, otherwise I would have used it there as well, because stationary waves এর problemটা কি? Is there anything going anywhere? No, right? Isn't it all in one place, just going up and down? So what becomes more easier there? Phases, you know, একটা উপরে একটা নিচে, right? But if things go somewhere, path becomes much easier. Okay, right, so let's move on. It is clear, tomra? When it's neither a whole number nor a 0.5 multiple. So any number between 62 and 62.5, any number in between, is actually just interference. Right, so let's move on. এখন খুবই ইম্পর্টেন্ট একটা জিনিস করবো, পেজ 60 তে। ওকে, সো কিছু লেখা লাগবে না, একটু স্ক্রিনে দেখো। রাইট, আমাদের সিলেবাস একটু দেখে আসতে রাখছি। সো এই দুটো ডান। Water waves, sound like microwaves. Okay. Basically, there's a derivation here, and I'm not really sure derivation the key syllabus are asking, but I mean for safety choir. Okay, it's a complicated derivation, unfortunately. So just extra হিসেবে করাবো. All right, so screen let me give you a premise of what we're going to do right now. So we know there's diffraction going on, right? And diffraction is when light passes through a small gap. What does the light do? Spread, right? So people have observed this for very long, and you can actually see light diffract literally with your own eyes, because as you start to close your eyes, right, and you start to squint, দেখবা যে তোমার যে টিউবলাইটের লাইট আছে দেখবা এরকম স্প্রেড হয়ে যাচ্ছে, and that's actually diffraction taking place, because as you keep, like, you know, trying to close your eyes, wouldn't there be a point right before you close your eyes when it's like really small, and that will allow light to what? Diffract. তার জন্য লাইটটা তোমার টিউবলাইট থেকে চোখে এসে স্প্রেড হয়ে যায়. So you'll start to notice that the light is like spreading out like that, right? So diffraction has been observed for many years, like people knew about this, right? But somebody, right, the same person who's you know, credited for young modulus, that person, right, he came up with an idea. He thought, what if I pass light through a gap, right, and I make many gaps, how would light interfere through each of the gaps? So let's see what he did. So his first experiment was this. He took a barrier, like in a dark room, right? In a dark room experiment. And what he did was he made a small gap here. A gap গুলোকে আমরা gap বলি না, because light কে diffract করার জন্য the gap that you need has to be what? Like what kind of size? Very small, because lighter wavelength into nanometer range, 400 nanometer, 500 nanometer, right? So the gap has to be really small. And very small gaps, okay, English, they don't call it gap anymore. Gap মানে কিন্তু বড়। Small gap কে কি বলা হয়? Slits. So it's like, very thin blade দিয়ে কাটলে যা হয়, that's the slit, right? So these are like really small, microscopic level. They modern day we use laser for them. Age they used to use literally another diamond piece use করে cut করা হতো, like as sharp as possible. So these are like really small gaps out there, right? And what the person did was he placed a light source here, and the light source that he used was termed as monochromatic. এই টার্মটা প্রায় দেখবা তোমাদের সিলেবাসে ইউজ করা হয়, especially in MCQs. What does monochromatic mean? Yeah, it's a source of a single frequency. আমরা ওয়েভলেন্থটা আনফরচুনেটলি বলে ফেলি, but একটা লাইটার প্রপার্টি অ্যাকচুয়ালি ওর ওয়েভলেন্থ না, কি frequency, because frequency is what the source produces, right? So monochromatic means a single frequency light here, okay? So single frequency একটা light source. And what happened was the light passed through the gap, and something interesting showed up here. Let me show you কি হয়. So light এদিক দিয়ে যাবে, এই গ্যাপের ভিতর দিয়ে পাস করবে, and as the light paper 2 আচ্ছা ওই রুমে থাকা আমি দিচ্ছি. So as the light passed through this gap, right, obviously what would the light do? Diffract, right? And the gap was perfect, মানে একদম custom made for red light, তার মানে একদম perfect diffraction হবে. So the problem is that এই জিনিসটা যে diffract হচ্ছে এটা কিন্তু দেখা possible না, because in front of you, are there light waves right now? Yeah, of course there are light waves in front of you, না কেন? But the problem is, can you see a light wave in front of you? No. So light wave problemটা কি? It's so small, right? You can't really see it. So if you want to see light wave, what do you need to do? Place something in front of it so that light hits it, and that light goes where? To your eye, then you see it. So unfortunately, the way we see light is when it bounces off things. You can't see a light wave in between two places. It's how it is, right? So এখানে কিন্তু light যাচ্ছে, but কেউ কিন্তু দেখতে পারবে না light যাচ্ছে. So কেউ যদি এখানে একটা বল রেখে দিত, what would the ball start to do? Glow red. What is falling on the ball? Light. Achha, so unless you keep something, you wouldn't be able to see the wave, right? So obviously we have to place something here, and the thing that we place is a screen. একটা হচ্ছে like a board যেখানে লাইটটা পড়বে, and that will tell us what's going on, right? So as I told you, this experiment was performed in a dark room, otherwise you wouldn't see the light clearly. The light passes through the gap, it diffracts and falls on a screen like that, right? Can you predict what would you see on the screen? কি দেখবা স্ক্রিনে? And where would the light be, if there's any light at all, or would the light have some kind of variation? What would you see? You will see a dark portion, as we go on. Dark portion or bright portion? Bright. It's very similar to this. If you take a light source, like as I hold it here, right, is it evenly spread out? Naki side gale it's fading out. Why? Yeah, because remember we did a formula I equals to P divided by 4 pi d square, where the further you go, what happens to the intensity? Drops, right? So এখান থেকে যে লাইটটা বের হচ্ছে, do you think the light travels equal distance everywhere? No, right? So isn't it spreading out like that? So if you see the light fall on the screen, where would you find the light to be the brightest? Center, right? So center notice korba that the light is like, very bright. Okay. And as you start to go to the side, you'll start to notice the light ki kortese, fade hoye jacche. And the fade in is essentially because of what? কিসের জন্য ফেড হচ্ছে? লাইটটা অ্যাকচুয়ালি কি ইন্টেন্সিটি লুজ করতেছে নাকি হচ্ছে ডিসটেন্সের জন্য এটা হচ্ছে? ডিসটেন্সের জন্য, right? So there's this trick question they asked one time where they said they use a curved screen. বুঝছো, স্ক্রিনটা ফ্ল্যাট না করে স্ক্রিনটা is like semicircle. How would the intensity be there? If you use a semicircular screen, right, ওইখানে লাইটটা কিরকম দেখতে হবে? It'll be same everywhere because the light would have traveled equal distance everywhere, right? So flat screen use করলে এরকম হয়, curved screen use করলে হচ্ছে it'll be same everywhere. And আমাদের এটা করতে হয়. We have something called a diffraction grating. আমরা next করব or next class ওইখানে we have to use a curved screen. Okay. Anyways, so this is how it looks like. And তোমাদের syllabus the requirement is to put this in the form of a graph. কারণ নালে তো sketch করাটা subjective হয়ে গেল. So you need to plot a graph for distance versus intensity, which is watt per meter square. And naturally, where would the value be the highest? Yeah, at the center, right? It is center সবচেয়ে বেশি থাকবে. So the graph that you get here looks something like this. It peaks at the center, and then as it goes there, it again drops. By the way, whatever happens here is symmetrical. Symmetrical মানে left এ যা হয় right এ same টাই হয়. So do you see the shape here? So this is the graph for what versus what. Intensity versus distance, right? So your মাঝখানে তোমার intensity সবচেয়ে বেশি, and then it falls and then goes back like that. Okay, so this is the graph that we get. Are you clear with this? Right. আচ্ছা, so কিছু জিনিস add করে রাখি এখানে. Intensity falls because of distance. Okay, it's screen. I'll give you time to copy. It's not even the experiment that we are looking for. It's a background. Right. So, তোমরা কি বুঝছো what is seen when diffraction takes place? So, it's into very basic activities. There is nothing actually to redo here. আমরা আগে দেখে আসছি এটা. So Young did something else. Let's look into his experiment. He thought, wait a second, এখান থেকে light enter করে lightটা এখানে আসে. তারপর lightটা এখানে এসে it gets bright here. What if I use another light source? Would this light come here and make this even brighter? So that was his thought process. If I use multiple sources, light will actually shouldn't it stack up and get brighter, right? So what he thought of was he'll trick the system, and his way of tricking the system was সে light source আর add করবে না নতুন সে কি করবে ওই original light source use করবে the one he had, but his plan was to make what here two gaps. And his understanding was একটা the light যাবে আর light যাবে দুইটা light নিজে interact করবে and then become double. And his overall thought process was he'll make a million gaps. Light will enter a million times, it'll stack up a million times. What do the brightness become? Million times high, right? That was his actual thought process. It actually came very close. I'll show you why. So what he did was he placed the light source here, right? And he allowed the light to pass through. And naturally, এই জায়গায় কি হচ্ছে? Diffraction. এই জায়গায় কি হচ্ছে? Diffraction. And the light travels like that. And then places the screen here to see what that outcome, right? And the outcome changes physics forever. I'll tell you why. What happened here was his expectation was it right, it'll be double right? And it's true. Right at the center, he found that the intensity of the light he found gets here exactly how much the previous value. Double. Okay? But then right next to it, right he found complete darkness. Light absolutely void of light, full dark, right? And then again, who showed up? A bright spot. Again, it's complete darkness. And again, bright spot showed up there. And this was a little fascinating because it's almost like you take one torch, you take another torch, and you point the torch at one place on a screen, and what do you see? Darkness. That's what actually happened. Because if you think of this, দুটো light source আসতেছে screen but light somehow এটাকে reach করতে পারতেছে না. Otherwise, why would you see darkness there, right? So this was what he saw. That when you use double slit, দুইটা slit যদি use করা হয়, it produces this pattern, and this pattern has a name. It's called the fringe pattern. They're like lines in the actual experiment, so they're called fringes. These are called fringe pattern, and these are caused because of interference. And now we understand that the bright spots that you see are because of what kind of interferences? Constructive, right? And the place where you see darkness is because of what interference? Destructive, right? So তোমাদের এখন যেটা করতে হবে is to learn the math behind this, and the math behind this is very important. In fact, it is everything. A chapter A, the math is everything. Okay, so let me label few things here. A মাঝখানে যে জিনিসটা দেখতেছো, this is they have names, so we need to give them names, unfortunately. So মাঝখানে যেটা থাকে, it's called the central maxima. The one at the center, ওটাকে central maxima বলা হয়. So এখানে গ্রাফ প্লট করতে হবে তোমাদের. গ্রাফটা আমি নিয়ে আসি একটু। Like how does the intensity vary? Okay. Practical use of this? There is no practical use, unfortunately. Why? No, he didn't invent it. He discovered it. He discovered a property of light, which is light can destroy one another through destructive interference. Prior to this, it wasn't believed like that. That two light sources can meet at a place, and what can they do to each other? Cancel out. This is the evidence of that. Okay, modern day it's very easy to observe, like noise cancellation headphones and whatnot, right? But back in the day, two waves will meet and cancel each other out. There was no evidence of it. This is the first ever evidence of it. Okay, so yeah, this is how it looks like. Now, একটা জিনিস একটু নোটিস করবো এখানে, এই সেন্টারটা is like very bright. It's actually how much brightness compared to the original light, twice, right? But পাশের bright spotটা কিন্তু অত high না, একটু কম. Why? Yes, because remember we did this experiment with the sand. Online class বলছিলাম যে sandটা ওই যে soundটা reflect করে back করে, and when the sound goes and reflects and comes back and interferes, অনেক energy loss হয়ে যায়. So the amplitude is not as high as before, right? Same জিনিস হচ্ছে. So এখানে basically কি হচ্ছে, this place is a constructive interference, but a constructive interference between two waves that have what amplitude? Low amplitude. And why do they have low amplitude? Because they have traveled further, right? So যত দূরে যেতে থাকবা দেখবা যে তোমার constructive এর amplitude কমে যাচ্ছে, and that's because they are constructive, but they're constructive between waves that have lost a lot of energy. Therefore, they're not as bright as the center. Okay, এটা real life picture যে এরকম দেখতে. So this is how it looks like in real life. Okay, আমি পাশে দিয়ে রাখতেছি. So you'll notice that the center is visibly brighter, right? It's so bright it's almost white in color. But you see, as it starts to go further away, it starts to dim out, right? So these are all what spots that you see here? Constructive interferences, and everything in between those gaps are what? Destructive interference, right? So also one more thing, is it like constructive and destructive, or is it constructive to destructive? There's a difference in what I'm trying to say. Constructive and destructive মানে হচ্ছে solid blocks, like constructive, destructive, right? Are constructive to destructive মানে হচ্ছে constructive fades to darkness and destructive. Which one is it? Yeah, it's the fade-in version. কেন? Because constructive তো constructive হচ্ছে, destructive হচ্ছে, মাঝখানে তো কি হচ্ছে? Interference. Wouldn't that create some kind of light, right? So that's why you have some light in between. Okay, anyways, this is how the graph looks like. So we need to name them. নামগুলো একটু লিখি আমরা. So the one at the center is called the central maxima. Then a first J zero টা আসে এখানে, this first zero that you see here, this is called the first minima. So নামগুলো কেন important we'll see very soon. This is called the first minima. Minima means a destructive interference. Okay, so the first minima. And then the next bright spot that you see is your first maxima. So it's your first maxima. And so forth. Do you understand? That's how the naming is done. So center is central, upper first maxima, second maxima, and first minima, second minima. Okay. Now, what we need to see right now is why do they happen? Like, what's the logic behind it? Okay. So this is very important to carefully. This is the math we're looking for. Okay. So why does a bright spot take place or form in the first place? Right. So you have your double slit here, gaps, and then you have your screen here. And we'll start with the central one. So jeta hocche is light will travel from here. Sorry, light will travel from here to where? কি আমাকে বলতে পারবে এখানে যে লাইটটা বের হচ্ছে কোথায় ট্রাভেল করবে? Like where does it go to? When the light that comes from this gap, right? Diffract করার পরে where does it go? Everywhere. So if I had to actually draw like the place where light went, right? It would look something like this. Everywhere. Yeah, semicircular মতন basically হচ্ছে এখান থেকে semicircle যদি draw করি এই যে যেখানে possible সব জায়গায় light যাবে. Every single inch you can imagine is covered with what? A beam of red light. Okay, so when I draw this red light, students sometimes get confused. Why is this going here? It's not going here, it's going everywhere. I've selected the one that's going here. আচ্ছা, so এখান থেকে যে light সব জায়গায় যাচ্ছে, let's assume the light goes to the center. একদম center reach করলো. Okay, now remember আজকে আমরা math করলাম যে if I know the length, right, I can count how many waves are out there. How do I do that? And how do I know how many waves are here? Yeah, divide by the wavelength, right? A length take যদি wavelength divide করি, I'll know how many waves are out there. So what we find is যে এই জায়গার মধ্যে হচ্ছে just বুঝানোর জন্য হচ্ছে this is not that important for our diagram. So যে এখানে একটা wave and that's another wave. Right, so you have these waves on this line. এরকম করে অনেকগুলো wave যাচ্ছে and এরকম করে wave গুলো গিয়ে they'll eventually meet the screen here. And in my case এই যে এই জায়গা আসলে হচ্ছে এটা একবারই দেখো, বাকি টাইমে তোমরা একটু ইমাজিনেশন ইউজ করো। Right, so complete waves reach করছে এই জায়গাটায়। Okay, how many complete waves have reached here? 1 2 3 4 5 6 7 8 9 10 11 12 waves have reached here. Do you understand? So এখানে কয়টা waves are there in this line? 12 of them. এটা কিন্তু imaginary hypothetical scenario. Obviously real life এ wave number বেশি হবে। Now my question for you is ওই নিচের গ্যাপ থেকে যদি same length travel করে একটা wave নিচের গ্যাপ থেকে to that point, right? How many waves would be there as well? মানে বুঝছো কি মিন করতেছি যে এই নিচের থেকে যদি এই সেম সেন্টারে আর একটা ওয়েভ ট্রাভেল করে how many waves would be in that line as well? 12 identical. So যেখানে 12 থাকবে and they'll go and meet there. So if there are 12 waves here, 12 lambda and 12 lambda, and they go and meet at this place, right? Didn't we learn today how to find out what happens there? What do? We find the path difference. What's the path difference here? 0, right? 0 na 12 minus 12, and 0 path difference results in what? Constructive interference. So now what will we see at this point? Yeah, a constructive interference, a bright spot. Do you understand what just happened here? This is what the central maxima looks like. Central maxima ta hoy when there are waves traveling from both sides, they travel equal distance. So what is the path difference? 0, right? Now let's try to understand why would the fast first one take place, the other one, right? ওটা পাশে কেন আরেকটা form হবে? So if I take gaps here again, and let's say I draw a line that goes from here to there, and a line that goes from here to there, do you guys agree that the lengths are not same? Right, one is more and one is less. Which one is more? Yeah, one at the bottom, right? let's say, just hypothetically speaking, that a উপরেরটার মধ্যে the number of waves that you see here এরকম is 14 lambda, আর নিচেরটার মধ্যে যেহেতু একটু লম্বা, it just happens to be 15 lambda. What is the path difference? 1 lambda. What would that result in? Constructive interference. So I will again notice a what here? Bright spot, right? This is the first maxima. So first maxima hoy when the path difference is how much? 1 lambda. So can you tell me second maxima যখন আসবে, that other bright spot, এটা পরেরটা, what would the path difference be? 2 lambda. And then again কি হবে? 3 lambda. So every maxima that you have, their name corresponds to what the difference is. So if I have a diagram where there's a 7th maxima, what does that mean? Yeah, so এখান থেকে যে কয়টা ওয়েভ গেল ওইখান থেকে কয়টা এক্সট্রা যাবে? 7. বুঝছো জিনিসটা? আচ্ছা, but that's not always the case. কেন বলি? There can be a scenario where this happens, which is you have the two gaps, right? And the waves are traveling through the gaps. And let's say a wave travels here, okay? And another wave travels here. But the number of waves that travel here, এরকম, number of waves travel here is 13.5 lambda. Just half a lambda went there. And the number of waves that traveled here is 14 lambda. What is their path difference? 0.5, right? And 0.5 is key hobe, destructive. So what do we see here? Not, yeah, exactly, darkness, because the waves cancel each other out. You get my point? So এরকম করে করে, the thing that I want you to understand is that as you keep moving like this, right, center কি হবে? Zero path difference. তারপরে কি হবে? 0.1, 0.2, 0.3, 0.4. এগুলাতে কি হয়? 0.1, 0.2, 0.3, 0.4 এ just interference. Then 0.5 reach করলে কি হবে? Destructive. তারপর 0.6, 0.7, 0.8, 0.9 এ কি হচ্ছে? Just interference. 1 এ কি আবার কি হবে? Bright spot. So that's the reason why as you keep moving away from the center, you get like a sequence of bright and dark and bright and dark, right? And these are called fringe patterns, right? So এগুলার হচ্ছে একটা লেভেল আমাদের শিখতে হবে। লেভেলগুলো আমি দেখাচ্ছি না bit, but তোমরা কি লজিকটা বুঝছো why they form these patterns on the screen, right? Because of the path differences. So what we need to know is এই এক্সপেরিমেন্টটা করার জন্য কিছু ইনফরমেশন ইউজ করতে হয়, ওগুলো একটু বলি তোমাদেরকে, মানে কিছু লেভেল থাকে। So the gap between two slits actually matters for us, and ওটাকে আমরা বলি a, এটাকে বলা হয় slit separation. Slit separation is the gap between two slits, okay? Alphabet গুলো খুব ইম্পর্টেন্ট, মানে সিম্বল গুলো অফিশিয়াল। This is D, capital D. This is what? Distance of the screen, like how far is the screen. তারপরে হচ্ছে you have these dark and bright spots on the screen, right? So this is the bright spot, this is another bright spot. এই দুইটা ব্রাইট স্পটের মাঝখানে যে গ্যাপটা, peak to peak, okay, this peak to peak gap between the two bright spot is referred as X, which is known as fringe separation. Fringe হচ্ছে এই লাইনগুলোকে বলা হয়, so it's called fringe separation. So you need to know these terms, okay? Lambda, sorry, A, X, and D. A হচ্ছে কি? Slit separation. D is what? How far the screen is. And your X is what? Fringe separation. Turns out, it was a groundbreaking experiment. If you use the value of A, X, and D, right, in a formula, it'll tell you what the wavelength of the light is. And that is, for now, it's not groundbreaking, obviously, but imagine 200 years back, somebody actually found the wavelength of light to be 400 nanometers. That's a very small value, right? Just by using this setup. So এখানে এই ভ্যালুগুলো actually, and that's the derivation that I'll be showing you next class, that you can use these three values here, combine them, and find the what of this light, the wavelength. Okay, ওইটাই হচ্ছে the overall formula that we need to learn. So yeah, this is it. This is the last hurdle of waves chapter. এটা শেষ হলে wave would be over. So next class I'll be doing this again. Sunday day I will be taking your class, okay, but it will be online only. Sunday day. Yeah. अच्छा, putting in good also.